All right, so let us now work on what we call the key features of our sine and cosine functions, the two basic what we call periodic function. They're called periodic function because one period of sine will just keep on repeating itself. So for sine, it always starts at the middle, right? At the midline, go up the maximum, go down the minimum until it goes back to the midline. Okay? For the cosine, one period, right, of its periodic function will be the horizontal distance between one of the maximum to the other consecutive or following maximum, right? Okay, so let's consider in here the following in terms of its notation. So y or f of x is equal to plus or minus a, and that's gonna be either sine or cosine of what? B, x plus c plus d. And those are gonna be telling us regarding the key features of our sine or cosine function in terms of what? A will deal with the amplitude, which is the difference between the peak and the trough, right? The crest minus the trough, that's the maximum y minus minimum y value all over 2. Half that distance is your amplitude. So in here, when you talk about amplitude, if this is gonna be the middle of this one, then the amplitude will be this, okay? Half the height, get it? So whatever the height is, get half of that one, then that will be our amplitude. Get it? It's always gonna be positive, all right? Next one, the B here will determine the period, but it's not the period yet. Okay, now how do we get the formula for the period? We use this triangle in here with 2 pi on top. That's one period for sine. B and P in here. So the B is the multiplier always for x. You always factor out that x out of the equation inside, okay? So how to get the period? The ratio between 2 pi and P. Okay, so again in there, the period is 2 pi over P. Okay, actually, B in here will always be the absolute value, right? Without considering the sign. Okay. C in here, however, is the number added to or subtracted to your x, again, when B is already factored out of the equation, okay? And that B is talking about the sign change. Sign change of whatever this C is, that'll be the phase shift. How much did it move to the right or to the left is gonna determine the what do we call the phase shift. Okay, guys. Next one in here. So in here, I'll put in here. Plus means you move to the right. Minus means you move to the left. Okay. Whatever that C is, you sign change that, then that will be the determining if it's going to the right or going to the left. Okay. The last one is the midline, right? That is the line that cuts your function into two halves, the upper half and the lower half, right? And the formula for the midline, y is equal to whatever that d is, right? And that d is also equivalent to the what? The average of the maximum and the minimum values. Okay, so we're gonna see all of those later. By the way, the domain will always be the real numbers, set of real numbers, and the range will be coming from the minimum and the maximum y values. Now, let us apply this one to a specific problem for our case. So this is a problem. Let's see how we're going to work on this one, okay? Let's read this problem and see how we can work on this. Krish, go ahead and please read this problem here first. Thank you.
Ferris wheel is 25 meters in diameter and rolling from the platform that is 1 meter up the ground. The social position on the Ferris wheel is level off with the lower platform. The wheel completes 1/4 journey in 10 minutes. The function h of t gives the person's height in meters above the ground t minutes after the wheel begins to turn.
All right, so let's start with that one first. All right, thank you, Krish. So let's analyze this according to our cubes method. Let's circle first. What are the given numbers? So 25, what else? There's a 6 o'clock position. Okay, what else did we see in here? 1 full revolution in 10 minutes. Okay. Okay. What else? That's it. Okay. Next, let's underline. What are the need to be underlined in here? So what is 25 meters, guys?
Diameter.
That's the diameter. Very good, right? And boarded from a platform that is what? 1 meter what?
High.
Above the ground, right? Thank you. So with that, let us draw that Ferris wheel first, right? So let this be the ground of the Ferris wheel, right? Let this be the, what we call the fulcrum of our Ferris wheel, all right? And let's do this Ferris wheel in here like such. Oops, all right? Got it, guys? Okay. Now it says the diameter of this Ferris wheel is 25 meters, right? So that means from here to there, that's going to be that 25 meters. Get it? Okay. Now, where's the 1 meter? That means this bottom in here, from here to here, will be what? That's our 1 meter. Are we good? Get it? What we did with our Ferris wheel? Okay. Next one. The 6 o'clock position on the Ferris wheel is level with the loading platform, right? So the 6 o'clock position is in here, right? And the loading platform should be in here, right? So that's the 6 o'clock position, right? Get it? Okay. And then it also says that the wheel completes 1 full revolution in 10 minutes, right? So that means from, if you start from here, right? So if you start from here, okay, let me color it blue, okay? If you start from here, you go 1 complete rotation, and how many minutes will it take you?
10.
10 minutes. Thank you. Paula, that's correct. So let's draw that one from here. That is what? At t is equal to 0, right? Going to what? You go up, and then you go down, right? And this is what? T equals what in here? 10 minutes, right? In 10 minutes, and that's 1 complete rotation, right? And 1 complete rotation is how much? 1 revolution. Okay. Okay. So that means that is what we call our period already, right? Are we good, guys? Get it? Now, let's read first in here what we're gonna do. Letter A. What did it say in there? What we're gonna do? Ari, let's read. What do we need to find? Thank you, right? Yeah. Amplitude, midline, and period. Well, first of all, let's talk about this. What part of the graph is this? The lowest point of the graph is called the what?
Trough.
The trough, all right, or the minimum y, right? And how much is that? It says what? 1, right? So the minimum is at what? 1, so that means that's 0, 1. Get it? Okay. Maximum in here. Okay, so that's the maximum, right? So what do you think is the maximum y value at that point?
26 feet.
So again, this is 1 meter. If you are in there, how high are you from the ground? Well, that is 25, and that is 1. So what's that in there, guys?
26.
26. Very good. So maximum y is 26. Minimum y is 1. Definitely this one is what? Another minimum y, right? Let's call it second minimum y. Which is what? This is what? 10, 1. And after 10 minutes, it went back to what? 1 meter above the ground. Get it, guys? Okay. Now, what formula did we have in there to get the amplitude? Zach, what did it say in there? How do we get the amplitude? What do you do with the maximum and minimum to get the amplitude? Let's see.
You divide it by 2.
Yeah. So subtract it first and then divide it by 2. Very good. Now, how do we get the midline? What do we do then? Maria, how to get the midline?
You do max plus minimum divided by 2.
Very good, right? So once you get the max and minimum, just get the average, you're gonna get the midline. Now, how do we get the period? Well, once again, it says what? 1 complete revolution, right? Equivalent to what? 10 minutes, right? And one complete revolution is how much? In terms of radians, 2 pi radians, right? But in here, in terms of time, that's 10 minutes for one complete revolution, right? So that means in here, that is your what? Get it? It takes 10 minutes to have one complete revolution, right? So your period is what? 10 already, right? So check on the period, 10. Let's get our amplitude. All right, so let's put it in here. Okay, amplitude. Let's color it a different color, purple. Get it? Right? So with that being said, we're gonna put it in here as such. What's the maximum again in here, guys? 26 minus what? What's the minimum? What's the lowest point of the Ferris wheel? 1. There we go. All over 2. So how much is that? 25 halves. And again, what's the unit for this one? Still meters. Right. What about the midline? Y is equal to 26 plus 1 all over 2, right? So which is 27 over 2. And again, midline is always going to be a line, right? It's always going to be a horizontal line, right? So that's y equals 27 halves. Get it? Okay, so let's see. How does it look like? Okay, so how does it look like in here? Ready? Okay. So I'm going to go to my Desmos. And this is what I'm going to do, all right? Let me just erase this one first. X this out. And see how it looks like in here, right? So, that's going to be, is it sine or cosine, by the way? Which among these two graphs does it represent? Cosine, right? But instead of cosine, it's going to be what? A flip cosine, right? So if you see this cosine, you flip that one, it should look like that. So when you say flip, you make it negative, right? So with that being said, this is what we're going to do. Let me just X this out, okay, and plug it in here as such, right? Y is equal to negative cosine, right? What's our amplitude again, or our A? 25 halves, right? So I'm going to put in here 25 halves, right? Cosine. What's my B? We don't know what our B is yet, right? But in here, our X is in there. Right, there we go. Plus, what's our midline? D, 27 halves, right? So I'm going to put in here 27 over 2. Right? Now, how do we get the period once again? Well, we said a while ago, the period we said is how much? 10 minutes to take what? In one complete revolution, right? Get it? Okay. But instead, to put it into equation, how to get our B for that? What do we do? So if you want this B, what do you do to the period? Get its ratio with 2 pi. Get it? Okay, so with that, then that means our B in here should be what now? 2 pi over P instead. And our P in here is 10. So that's going to be what? Pi over 5 for our B. Get it, guys? How we got our B? So let's put it in here. See our B in here? Let's plug it in as pi over 5. Okay, and let's see, how does it look like? So, I'm gonna go to settings and put it in here, right? What's my x-axis? So my x-axis from where? From 0 to, how many minutes does it take? 10 minutes, right? One complete revolution. Get it? Okay. My steps in here is by seconds. So instead of pi, I'm just gonna make it what? By seconds, right? Okay, so 0, 1, 2, 3 until 10 seconds, okay? Again, 10 minutes. Y. So my Y is from the, I would say from the ground, 0, up to, what's the highest peak or highest point of this Ferris wheel?
26.
26, right? So, well, we can put it in there as 26. Are we good, guys? All right, and let's verify. Does it look like what we are expecting it to be? Well, we said a while ago, you started at 6 o'clock at the bottom, right? Which is what? What is that? That's 1, right? 1 feet, 1 meter above the ground, right? Okay. After 5 minutes, you'll be at the peak, which is how much? 26 meters up, right? How high is that 26 meters? Oh, really high, right? I don't like Ferris wheel, guys. If you go down, after 10 minutes, you'll be back 1 meter above the ground, right? And hopefully we're done with that, whole rotation and won't do it all over again. Well, not unless you enjoy the Ferris wheel, right? I don't. Okay. Questions regarding that one, guys? Get it? Okay, so at least we can visualize how does it look like, right? Anyway, where is that midline? So we said the midline is what? Y equals what? 27 over 2, right? Let's see where's that midline at. You see that line in purple? Okay. Does it split your up and down halfway? Yes, right? We good, right? So that's what we call the midline, right? What is our amplitude? We said it's 25 halves, right? So do you think that from here to there, that's 25 halves? Or from here to there, that's 25 halves? Good, guys? Is it 12.5? Right? Okay. What else? Range. What do you think is the range for this one? So I said in here, the range is from where? From the minimum to the maximum, right? So if I put in here, by the way, in decimals, you can only put in the range in terms of what? Inequality notation, right? We cannot put the interval notation for such. So let's put it in here. What's that again? We said 1, the minimum, right? Okay. Less than or equal to, less than or equal to y. We're talking about the range, right? Okay. Less than or equal to, again,
26.
what's the maximum? 26. Did we say 26? Yep. Okay, let's see. Does that cover the entire path of the Ferris wheel? And yes. Get it? Okay. So we can visualize like, okay, how does it look like? But again, make sure that the graph settings that you put make sense with the problem. Get it? Okay. What's next? What else is on the problem, by the way? Let's read some more regarding the problem. Where is that one? Okay. Oh, find the formula for the height. So we have the formula already, right? And that basically is our formula, all right? Let's put it in here. What's that again? HT, or the height of the Ferris wheel at that time, T in minutes is equal to what? What did we say in there? Negative, right? 25 halves cosine, right? Our B, we said to be pi over 5, okay? X, there's no phase shift. It didn't move, right? Okay, because the fulcrum is just stable in there, right? So it's just going to be that. Plus, our D is, what did we get? 27 halves, right? Again, we used cosine simply because it started from down, going up, going down. So basically this one, but flipped horizontally, right? So that's why we put in a negative in there instead. Get it, guys? So again, the negative means you flip the cosine, okay, to consider the minimum and the other minimum, right? 25 halves is the amplitude. Pi over 5 is B, but again, the period is 10 meters in one complete revolution. And the midline is, once again, do not forget, y equals 27 halves. Because a midline is always a line, so it's always an equation. Y equals D. Get it? Okay. What's the last question? What did it say here? Oh, it's lost where it is. Okay. Letter C. Let's figure out how to answer that one. Jillian, let's read letter C. What did it say?
How high off the ground is the person after 5 minutes?
Okay, so let's figure it out, right? Going to your decimals. After 5 minutes, where is, or how high is the Ferris wheel at? 5 minutes. So that's been x is equal to what? 5, right? And let's see what point that one is. Get it, guys? Right. So after 5 minutes, the Ferris wheel is how many meters above the ground, Amaya? 26 meters. Very good. Questions? All right. Thank you.